haven't done the essay. Oh, yeah. And I can't tell anyone. That's really good. I don't know what I got yet. Do I have to throw this away now? No. Look, it's so pretty. It's so pretty.
Okay, so today we're doing some solving inequalities. I'm going to show you two algebraic and two graphically, okay? So yeah, I hope you did this in algebra 2. Well, yeah, I don't think you did. We did it in algebra 1. You'll remember. Maybe. This is review. See how I wrote that down? Review. If I asked you to solve the absolute value of x minus 3 is less than or equal to 5. So I find that it's helpful to understand what that means, because what you're going to do is solve two inequalities, and here's why. Okay? That absolute value, that symbol, does anybody know what it means? It could. Let's even break it down further. Because what does absolute value really mean? Closer.
That it can only be positive.
On a number line, what does absolute value mean? Distance from 0. Okay, so the definition of absolute value is it's the distance from 0. So if I said to you, hey, sidebar, something has an absolute value of 3, that means on a number line, here's 0, it has to be 3 away. There's two answers to that. Could be over here, that's positive 3. It could be over here, that's negative 3. That's the why. That's why we solve two equations, because it represents the distance from 0. So if I told you this, hey, the distance from 0 has to be less than or equal to 5, that means it could either be 5 that way, has to be in between 5 that way, or in between 5 that way. And so the way that we break that apart then is we write it as a compound inequality. This is x minus 3 has to be less than or equal to 5. That would be 5 or less on this side. But then it has to be greater than or equal to negative 5. So when you see an inequality pointed that way, you write it as a compound inequality. And really we write it this way because you're solving two inequalities. You're solving this one, like if I were to cover it up. Some teachers say write them both out. I don't need you to write them both out, but you're solving this one and you're solving this one. How would you get x alone? Yes. So people do crazy things. Remember, you're still trying to get x alone. Don't start adding 5s and adding 5s to... No, x in the middle, get it alone. You want to add 3. So you're going to add 3 to this inequality and add 3 to this inequality. And then I'd be left with negative 2 less than or equal to x less than or equal to 8. That would be the solution of that one. Okay. This is also review. And actually, I know that we talked about this in Algebra 1, right? Don't make me. Yes, we did these in Algebra 1. Chris, yes we did. All right. How about 3x minus 2, the absolute value, is greater than 4? Okay, what this means is the absolute value of this expression, whatever it is more than 4 away on a number line. I just like to draw, I like to understand what we're talking about. More than 4 away would mean, well, wouldn't that mean 4 and higher over that way? Is that making sense? What would more than 4 be on this side? Negative 4, but I'd have to be going this way. When you're solving an absolute value inequality that's a greater than, you can't write it as one, because it's not between, you have to solve the two separate ones, because they're two separate things. So I'm going to take what's in there, and I'm going to set it greater than 4. So one of them is 3x minus 2 is greater than 4. Or the other one is 3x minus 2 on this side would be less than negative 4. So some teachers will say, hey, you do the one is what it looks like, and then the other one you flip the sign and make it negative. I don't know how you want to remember it, but this is the y. That's why you're doing it. All right, would you solve those two for me, please? Don't write these as equal signs. This is x has to be a value greater than 2. That means any value greater than 2 would work. And x has to be less than negative 2/3. Ooh, reminder. When you're solving inequalities today, if you run across a negative coefficient where you have to divide by a negative, do you remember what you have to do? You got to flip that inequality sign around. Okay. That's some algebraic stuff. Let me do two that we would solve using graphing calculator. And then oh gosh, so I'm being too easy. Then you're going to get the rest of the time to work. You don't think I'm being too easy?
No, of course not. This is impossibly hard. I don't understand how you learn this.
So some things that I would expect you to solve graphically. And actually later on this year, we're going to talk about how you could find, because we could find using quadratic formula or factoring maybe, where this equals 0. So what if I asked, where is it greater than 0? So I'm going to show you that on the graphing calculator. Okay. So to solve this problem, what I'm going to do is, graphically, this is going to be quadratic. It's going to be a parabola. Greater than 0 on a graph means above the x-axis. So we're going to go ahead and solve this like we would an equal to 0, because we're going to have to figure out where it's equal to 0. So let's put our equations in. Don't forget to put the y equals 0 in there. Anyone remember what we do next to get the graph to show up? Zoom 6 will give us the standard viewing window. 6. Now we're going to go ahead and we're going to find both those intersection points. We're trying to find where they equal 0, because then I'm going to tell you, hey, it's going to be after that point, right? Then it's going to be positive, and then before this point. So we have to figure out where it equals 0 first. All right. So first I'm going to solve where 6x squared minus 5x, I don't know what's going on with that, x equals 0. What next? See if you remember. Second. Calc. 5. All right, enter, enter, and we got to get closer to this one. X equals negative 0.5 is what I got for the 1. Can somebody confirm that? Just give me a thumbs up. All right, thank you. And 1.3 repeating. Okay. I'm trusting you. All right. So then we look at the graph. And we say, remember, I wanted to say, when was it greater than 0? So I want to know, when is this above 0? So it's above 0 when x is after this point, right? Because when x continues to go this way, isn't the graph going to continue forever to go above the x-axis? So I would say for this one, the solution is x has to be greater than 1.3 repeating. And the other one is before this value, because when x is less than this value, then the graph is also above the y-axis. So I'm going to say x is less than negative 0.5.
Wouldn't it be y is greater than 0 then? Wouldn't it be y is greater than 0 at that point?
Yes.
Oh, that's what you're looking for?
Mm-hmm.
Oh, okay.
When I'm solving this, what I'm looking for is when this is the output, because this is like y equals this.
Okay.
When would the output of this function be greater than 0?
Oh,
Okay?
okay. Makes sense.
All right, what's doing that's not 0? So this will be our last example, I think. Yep. So when will the function 2x cubed plus 2x be greater than 5? All right, so there's two different ways that you can do this one. If you wanted to, it's going to look different on the graph. The solutions are going to be the same. You could move this 5 to the other side and still then find where that new function is greater than 0. That would work, okay? If not, then what I'm going to do is I'm going to actually compare this function and this function. So I'm going to put this one in y1 and this one in y2, and I'm going to figure out when is this function going to be greater than, that's going to be above this function. Okay, so let's go ahead and put those in, please. Clear, just clear. That's what I'm going to do. Okay, so this time my line's up here. This is the line at 5. And hopefully we can all agree that whatever this intersection value is at x, after that point, doesn't the x cubed graph look like it's going to be greater than the line at 5? All right, so let's find where they are equal. Okay, and it's very different than the ones we had before. The ones we had before were all exact answers. I'm getting 1.114. So you can either truncate or round. Okay, I usually say, just because in getting ready for calculus, if you take calculus, we have 3 decimals we always round to, and you may truncate or round. Okay, so I would accept x equals 1.114 or 5. And it's after that value. And as far as like, hey, when you're doing this on a test or in your homework, what do I want to see? I want to see just a little sketch. So, there you go. So oh, you can't see what I wrote. There's my little sketch of my picture. And that intersection point is 1.1147. So, what's my answer then? Not equals, it says so after that value, so after x is 1.11, I'll go with the rounding, 5 is the solution.